I'm Anil Kumar, and in this video we'll find inverse of linear functions. I've taken three examples here. They are kind of unique. One is the general linear equation in slope and intercept form, y equals to 2x minus 3. Then we have two special cases, y equals to 5, which is, as you know, a horizontal line. And then we have y equals to x, which is a diagonal which cuts across the coordinates into diagonally, right? Okay. Now let us see how to find inverse of these functions. We'll explore with the slope intercept form, y equals to 2x minus 3. One way to do it is to reverse operations, right? So that is first method, which is kind of unique and very good to immediately get the inverse of the given function. So we'll do reverse operations to get inverse of the linear function y equals to 2x minus 3. Now reverse means kind of like this. To get the output y, input is multiplied by 2 and then you take away 3 from it, right? So that is the function. So what is happening here is, to the input we multiplied by 2 and then take away 3. Now inverse function will give the input when the output is fed. So that's the reverse operation, right? Now how do you do the reverse operation? The operation is times 2 take away 3. Reverse will be add 3 divide by 2. You understand? So the reverse operation will be, we can write that as f inverse as to whatever input is there, add 3 and then divide by 2. So that becomes the reverse operation, and this becomes inverse of the given function. Now in this particular case, since it is also a function, I'm writing f inverse x, right? So it is a function. Now let me teach you another method of finding inverse, and that is when we swap and solve. Now that is the general method which can be applied to any function. So swap and solve is kind of like this. We have x and y. So you replace x with y and y with x. That is the first step. So when we swap x and y to the equation y equals to 2x minus 3, we'll get x equals to 2y minus 3. And now this is the first step where what we have done is we have done the operation swap. And now let us solve. Solve for y, right? Solve for y. So we'll bring 3 to the left side. We get x plus 3 equals to 2y. And then we'll divide by 2. So we get x plus 3 divided by 2 equals to y. And now we can write that the inverse of the function is, you could also write it like this, half of x plus 3 over 2, right? It is same as x plus 3 divided by 2. So these are two general ways of finding inverse algebraically, right? So these are algebraic methods. Now let's look into two cases. Here we have y equals to 5. This is indeed a very special case, right? Let me sketch and then show you how this function will look like. Y equals to 5 means a horizontal line, correct? So that is y equals to 5. Now inverse of this will be, if we use this method swap and solve, there is no x in the equation, so y will be replaced by x. So when I replace y with x, I get x equals to 5. So x equals to 5 becomes the inverse of this given function. X equals to 5 is actually a vertical line, correct? So x equals to 5 is a vertical line, which is kind of like this. As you can see, this is not a function, right? This is x equals to 5. It is not a function. So when you do inverse of a linear function, you may not get a function. X equals to 5 is the equation of the inverse of y equals to x, right? Now let's do the last one, which is very special case, y equals to x, and if I swap I get x equals to y. Solving for y, we again get y equals to x. So here what we see is that the inverse of the function is the function itself, right? So in this particular case, what we notice is inverse is the function itself. So inverse and function are same, right? So are exactly same. So that is how this is a very special case. I hope with this we have covered three scenarios for linear functions and their inverse. In the first one, what we notice is that a straight line has an inverse which is a function, and in this particular case domain range is all real numbers. In the second case, y equals to 5, the domain in this particular case was, let me write down, in this particular case, let me write domain range. In this case, x belongs to real numbers and range is y belongs to real numbers. So this is for the function, right? This is for f of x. And for f inverse x, what we notice is that the domain and range are still the same, right? X is also real numbers and the range is also all real numbers, correct? Now in the second case, y equals to 5. In this case, as far as the function is concerned, domain is, it could be any value of x, right? So x belongs to real numbers. However, in this case, range is just a value 5. So y equals to 5. That is the only value, correct? Now, if you do inverse, which is not a function as you have seen, what happens? Domain and range swap, right? So the domain for us will become x is equals to 5, right? So x equals to 5 is the domain. As far as the range is concerned, range becomes y belongs to real numbers. So whenever you do inverse, the domain and range swap. In the last case, you can write domain and range, and both you see function and its inverse are exactly same. So we have written inverse of the function is the function itself, and in this case we know domain is x belongs to real numbers and range is y belongs to real numbers, correct? As it is for most of the lines, right? So y equals to b, y equals to 5 in this case is a very special case. Most of the time, inverse of a linear function will be a linear function, except for an exception like that, where the slope is 0, and domain and range will be all real numbers, as we have seen in this video. I hope that helps. Thank you, and all the best.